All right, good morning. Happy Tuesday. Today we're going to be going over 10.6 again. So a few announcements. Once again, it's Tuesday. So you have a 10.4 to 10.5 quiz on SchoolNet. Now, if you don't get started with this quiz by 10 p.m., you're just not going to have enough time to finish it. So this is due today at 10 p.m. Well, you should start by 10 p.m. It's a time test and it's due at 11 p.m. So that's today. Wednesday, Thursday, we'll be doing 10.4 to 10.6 review, because Friday we have a 10.4 to 10.6 quiz back on SchoolNet. So keep an eye out for those, and again, we're going to review a couple of our theorems. So if you remember, when we were intersecting chords inside a circle, so these are chords, CD is a chord and AB is a chord, because these are segments that have their endpoints on the edge of the circle. And again, anytime I'm intersecting chords inside a circle, what we're doing here is we're going to stay sort of within one chord here. So I'll do one part of the chord 4 times the other part of that same chord. So 4 times x is equal to 7 times 8, or 4x equals 56. And then I could divide by 4 and solve for x equals 14. So just as a review, why don't you guys look at number 2. We're going to do the same thing here, but there's a little bit of a difference here. We've got a binomial, an x plus 3. So we'll do the same process. We'll still take 9 times the other part of that same chord, x plus 3. And we'll say that is equal to 3 times the other part of chord CB. So 3 times the other part of that chord. But what do we have to be careful about here? We've really got to look at, we've got a binomial multiplied by a single number, so I really need to be careful about distributing to both terms. So I've got 9x plus 27 equals 12x minus 3. And then I could go about solving for x here. So why don't you guys pause the video and finish solving this one for x, and then you can check back in a second. So this would be 3x equals 30, x is 10. All right. Now why don't you try setting up these last two here and solving for x. So again, I'd like you to pause the video one more time, and I'll leave this up here so you've got something to reference. Alright, so let's get started here. So this part of the chord is 6, and what's the second part of the same chord, ED or DE? Well, x plus 9 is the other part, so 6 times x plus 9 is equal to x, and what's the other part of this chord? x minus 9. And we'll solve this one here in a second, but I'd like to start with the other side. So 3, what's the other part of that chord, is negative x plus 4. And let's do the second part. X times the other part of the chord, x minus 4. Okay, so once you've got this set up down, feeling pretty good about that. Again, we'll have to distribute, so 6x plus 54 equals x squared minus 9x. And we're going to end up factoring these last two problems here. So here's what we're going to end up doing. We want to get everything on one side of the equal sign. So I want to get this stuff here. I want to get this stuff over there. And what we're going to do then is we'll have to subtract 6x. So 54 equals x squared minus 15x. And then I'll just have to subtract the 54 to get it over to the other side. So my final sort of format here, I'm going to have x squared minus 15x minus 54 equals 0. And we're going to end up factoring this to solve. So really we don't even have to worry about that too much. Really what we're trying to do is we're trying to factor this. So anytime you get an x squared, do your best to set it up in this format so that we can factor and solve. And how do I factor these things? Well, anytime I've got a quadratic like this, I'm going to look for my factors of 54, or negative 54, that combine to get a negative 15. So I've got, 2 and 27, 3 and 18, so it looks like 3 and 18 is going to work, right? Let me just make sure. All right, that appears to work. And if I want them to get me a negative 15, well, then I need a negative 18 and a positive 3. So x plus 3 and x minus 18. And once we get to this final step, we're looking for what number for x makes each one of these expressions equal to 0. And what we're going to end up doing is we're going to look at x equals 18, because 18 minus 18 gets me 0. And x equals negative 3, because negative 3 plus 3 equals 0. But let's think about the context of this problem. Can I have a segment length here of negative 3? Well, I can't measure like negative 3 feet. So we're never going to worry about the negative answer. We're not going to take this one. We're just going to take the positive root of our quadratic. So I'd like you guys to distribute here number 4, and then try to get to this step. Try to get to your quadratic form, your sort of standard form there. So pause the video and distribute and try to get into this format. Try to get to that step for me. So negative 3x plus 12 equals x squared minus 4x. And again, I want to get all of this stuff over here. Over there. So I can add 3x and subtract 12. And I can get x squared minus x minus 12 equals 0. And remember, we really don't need to worry too much about that equals 0 part. So hopefully you're with me up to this point. And now what we're going to do is we're just going to factor this. So let's factor that. So I want factors of negative 12. Well, I can have 6 and 2, and I want a negative 1x. So they need to combine to negative 1. Well, 6 and 2 isn't going to work, but let's see, maybe 3 and 4. Yeah, that would seem to work. And if I want a negative 1x, if I want these to add or subtract a negative 1, well, then I need a negative 4 and a positive 3. So x minus 4, x plus 3. And now we're going to find the roots here, so what numbers are going to make these two expressions equal to 0? Well, it would be positive 4 and a negative 3, and we just don't worry about the negative. So we get x equals 4. And we'll see a little bit more factoring like this in a minute, so just keep that in the back of your mind, your factoring skills that we worked on earlier in the unit. So here we did, one part of the chord times the other part of the chord. But what do we do if I have secants instead? These segments that are cutting through the circle. Well, this one's a little bit different. This is where we took one part of the secant times the whole secant. And this one can be pretty tricky, I understand. So let's work out a couple of these together. So what's the part of the secant outside the circle? We'll always start with the part outside the circle, is 9 times, and what's the whole secant? What's this whole secant right here? This is where we need to be very careful. So the whole secant is, I can take 9, and I can add the other part, x minus 9. For example, if I had a segment here that was 9 and 14, then to find the whole segment, I would just add 9 and 14 to get 23. So here I just added the two pieces. The 9 and negative 9 reduced to 0. So 9 times x equals, now let's do the other side. 2 is the outside part of that secant. 2 times, again, if I add these two pieces up, if I do 2 plus x plus 2, it'd be x plus 4. So let's label this, it's the part outside the circle times the whole secant. So I've got 9x equals 2x plus 8. And you're going to get a lot of fractions here today, so don't worry too much about strange decimals. And I can subtract 2x, 7x equals 8, and x equals 8 over 7. So why don't you guys try this next problem here. Again, be very careful. It's the part outside times the whole segment. So why don't you pause the video and just try setting up that very first step for me. All right, so we have 5 is the part of the secant outside the circle. And now what's the whole secant? Well, 5 plus 11 is 16. Let's do the same thing over here. I start with 7. So that equals 7 times. And now what's the whole secant? Well, that would be 7 plus x minus 2. And I can combine my like terms to get x plus 5. So don't forget, we really need to be careful to distribute to both parts. So I get, is that 80 equals 7x plus 35. So 7x equals 45. X equals 6 3/7. Or if you want to just write that as 45 over 7. It's typically how I would write it. Okay, why don't you guys pause the video, try these very last two. I think you'll be able to do those. So try those very last two problems. I'll leave this up here as like a reference for us. And then we will move on and finish this very quickly. All right, so I've got 8 is the part of the secant outside the circle. And now what's the whole secant? Well, if I add the two parts, 8 plus x minus 5. Now if I combine the like terms of 8 and negative 5, or 8 minus 5, I get x plus 3, because 8 minus 5 gets me 3. That's going to be equal to, let's do this in blue, 6 times, and what's the whole secant? That's 6 plus x minus 3. If I combine these terms, then I get, after I distribute, 8x plus 24 equals 6x plus 18. And because my Apple Pen is going to die soon, I'm just going to leave it at that step. And I'm going to have you guys finish that one on your own. So let's try setting up this last one here. 3 is the part outside this circle. And what is my whole secant here? Well, that's 3 plus 13 is 16 equals part outside the circle 2 times. Now the whole secant is 2 plus 6x minus 2. Well, what do you notice about this right now? How can I simplify that? Well, my 2 and negative 2 combine to get me 0. So these are gone. I'm left with just 6x. And, you know, again, because this Apple Pen's going to die, I'm just going to leave that for you guys to finish. And you should get x is 4. All right, our very last problem type. Similar idea. You know, here we're still doing the part outside the secant times the whole secant. So part outside the secant times the whole thing there. It's just that here, on the other side, the part outside the secant, well, that is the whole secant. But that doesn't change our process. So we're still going to do 2 times, and this whole thing is 2 plus x plus 4. And I can combine my like terms to get x plus 6 equals the part outside the circle. But again, what's the whole secant here? Well, the whole thing's just 8. So once I distribute, 2x plus 12 equals 64. And then I could solve for x. And x is 26. 52 divided by 2 is 26. All right, why don't you guys set up just your first step in this next one here. If you feel like you can go farther, that's fine. And then you can pause the video and see how it went. So here I've got x is the part outside the circle. But be very, very careful here. What's the whole secant? What's the whole thing here? Well, it's not just x. It's x plus x, or 2x, equals the part outside the circle times the whole secant. Part outside the circle is 5. The whole secant is 5. So we're looking at 2x squared equals 25. And how in the world do I solve this particular equation? Well, what am I trying to solve for? I'm trying to solve for x. And what do I need to get rid of that's with this x squared? What needs to go away from this side of the equal sign? Well, I need to get rid of this 2 somehow. So I can divide the 2 off. I get x squared equals 12.5. And then how do I get rid of that exponent? What's the opposite of squaring a number? Well, the opposite of squaring is square rooting. So x equals the square root of 12.5, which would be, somewhere in the mid threes, 3.4, 3.5, somewhere in there. So again, why don't you guys try setting up just your first step of these last two. These are the last two problems we'll have for today. And then we can move on and prepare for our 10-4, 10-5 quiz for the day. All right, so let's look at this one here. I've got part outside the circle is 10. Part inside, or sorry, not inside the circle. Part outside the circle is 10. The whole secant here is 10 plus 10, or 20, equals, now let's see, what's the part of this secant outside the circle? What's x plus 2? And the whole secant is x plus 2. So I've got 200 equals x squared plus 4x plus 4. And again, think about what we did earlier up here. We tried to get everything on the same side of the equal sign. So we'll do the same thing down here. So I want to get that 200 over to the other side. I can subtract 200. So I'm left with x squared plus 4x minus 196 equals 0. And since we're factoring, we really don't need to worry about that equals 0 part. Okay. Now this is where it's going to get a little bit trickier if you don't have a calculator, a little bit time consuming. Because you've got to find your factors of 196. And I'm going to cheat a little bit. So give me a second. Just going to work this out really quickly. Well, you know what? Let's just leave it at that for now. My phone just died. That was my calculator. So we'll do the same thing over here. We've got 6 is the part of the secant outside the circle. And what's this whole secant? Well, that's 6 plus x plus 4, which gives me x plus 10, because the 6 and 4 combine to get me 10, equals, and what's the part of the secant here outside the circle? That part is 10, and the whole secant is 10. So I've got 6x plus 60 equals 100. And this one's kind of nice. we can just solve. We don't have to factor or anything. So 6x, if I subtract the 60, equals 40. So x equals 40 over 6, which is 6 2/3, or 6.6 repeating. All right, so we've got a Zoom meeting at 11. Feel free to jump in on that one, and don't forget, you've got to take your timed quiz today over 10.4 and 10.5.